We should send one slide. I'm not sure who we send it to. Deborah, who do we send the report slides to, since we don't send them to you now?
Oh, to John.
Ah.
But you can send it to me.
Thank you.
So that you, otherwise we just say.
We'll send a slide to you. We'll send a separate copy to you, Brian, to finish up.
Anyway, the report.
Unless there's a problem, we'll send you a report. We'll send her the one slide report she wants and keep it moving. I will be there. If he's there as well, that's great, but I'll be there. Should we ask the people at the back to close the door and we'll get started? Should be 3 minutes after.
Hey, how's it going? Good. Getting your spare router, firewall thing here? 1 p.m.? I was just trying to get a firewall to do V6 tonight. Sure. I can get it. You can get PM, no problem. You guys were supposed to sell me a used one. Oh, okay. Just curious. Yeah, we'll work something. Sure. Absolutely.
Yeah.
So hello everyone, let's start the meeting. This is the Lisp working group. We will start with your favorite, the Note Well, which you should have already read when you registered to the IETF meeting. Some administration stuff, as usual. Here you have the pointers to the materials page, the audio streaming. We have our secretaries, Wasim and Damian, that will take the notes, the minutes for this meeting, but we need a JavaScriber. Is anybody online and willing to volunteer as a JavaScriber? The volunteer will have a star sticker that we should give out as necessary. Any JavaScriber?
I will try to cover it.
Okay, thanks. Next, the big news. We are relocating. As you know, there is an ongoing effort in the IETF trying to balance the workload in the different areas. So the decision has been that the Lisp working group will move to the routing area, okay? Which also means that we change a referring ID. So Brian Aberman was our ID so far, and starting right after the IETF week, we will have Deborah take over. And that's the main news from administrative point of view. Our work will not change. We have our charter and we'll stick to them. And we make a point as well on this. This is the list of active documents that we have. I put a green dot on the documents that basically are done, meaning that we handed over the document to Brian so far. In the future, we will do it to Deborah. We have two yellow dots concerning two documents that are close to be done. One is the Lisp TDT document. Just came out from the working group last call, and so he's waiting for the shepherd to do the write-up, basically me. This will be done hopefully this week. And we have the impact document that is actually right now in last call, and Damian will give an update on this later during this meeting. Then Dino will give us an update as well on the crypto document, the data plane confidentiality document. We also have two other active documents that we need to discuss about, which are LCAF and SEC. I mean, there will be as well an update on threats, as usual. This is the oldest document that we still have here in the group. And so I would like to ask actually the authors of the LCAF and SEC, what are the plans for these two documents, because if they are stable, we should try to go and move them forward. So Dino, can tell us something about the LCAF? Is it stable for you?
This is Dino. So for the popular use cases like instance IDs that we use for VPNs, which I know is not a chartered use case, that's been pretty stable and it's been used, and I think there's some production deployments of that. There are implementations of the other type of LCAPs, geocoordinates, for example, and there's a couple use case documents, use case individual submissions that depend on stuff there. I personally am doing experimentation on all the LCAF types. So it depends. Joel and I have had various conversations over many years about how to go about this. If this is something we should just latch on and push it forward, or do we keep it a living document so we could experiment with more LCAF types? One example is like the guys from UPC want to experiment with a JSON dictionary array being returned back after you do an EID lookup. So that's something that's put in there and what the encoding could be, but there's little experience with it so far. So for those sorts of things, I don't know what the status. So the documents, parts of it are stable and parts of it's experimental to try new things. So I guess I send it back to you guys to help decide how we should approach this.
State your name.
This is Daryl Lewis, Cisco. I want to say that in our implementations, we're actively using and actively considering creating new LCAF values, but I don't believe that that should stop the basis of this document for putting a framework together that includes a registry for future LCAFs being created. I think that we need to decouple those two things. In my opinion, I don't believe we need to leave the document in draft format to allow for changes to that portion of the document.
Yeah, I was going to say the same thing, and sooner or later we have to close the document at some point and create a registry anyway. We cannot keep it a live document forever until the end of the Lisp technology, right? So
yeah, so that's fine. I mean, the first part of the document that talks about the general encoding and how additional types can be added, the additional types can be defined in a registry. So you want that to start happening.
I will help you to refine the IANA consideration and how to put it in.
Sounds good.
My recommendation as a co-chair is that we focus this document on the ones that are stable and known to be stable, and then establish the registry and establish procedures, simple procedures for using the registry so that we can keep doing new ones. Because I'm not saying stop doing the new ones. You're doing interesting things with it.
So the types that are stable, should they be duplicated in the registry in this document?
Yeah, that's how you do it. The way you do this kind of thing, the document defines the
No, but
first
we take a
set,
snapshot in time, which is
and
not-
you populate the registry with the initial set from the document, and then the registry gets to add more things, each of which have their own document citations. And it's very straightforward.
But the ones that are in the document right now, not all of them should stay in the document because
Right.
they're more experimental. So we're going to have to make a subjective call on which type should stay in versus
Yeah,
not.
that's subjective, but let's just do that.
Okay.
Excellent. So, concerning the LispSec document, is any of the authors wants to have a comment?
Hi, this is Vina Ermagon. So I think the LispSec can be moved to Pascal. The document has been stable, capturing the data plane to control plane security for a while now. So
Okay, let's do it that way. I will review the document because for a while I didn't follow all the changes to you added to the document, and then we will decide if the work is done, then we go for last call.
sounds good.
Okay. Thank you. This is our list of milestones. Where we are, we need to start thinking to work on this last document for which we don't have anything so far, which summarizes a little bit what we have done and what are the implementations. But the good news is that we are getting closer to having all the work done. We have 2 documents that are within the AD and the ISG. The DDT, as I said, is waiting for the write-up. Impact is in the last call. Threats, we are getting closer to having a final document because, as Damian will discuss later on, we have a first part which we can say we have a consensus on, which is pretty stable. Is the second part that we need to work on, but is smaller. And yes, the missing document. So the agenda for today is pretty simple. After me, there will be Damian talking first, making a point on the threats document, the impact document. Then is Dino coming up with an update on the crypto document, which ends the part about the working group documents. And then we have an update on the signal-free multicast by Dino. Okay, and then Alberto will present us a young model for Lisp. Okay, and then apparently we have plenty of time that we can use to discuss on the next step or any other issue you want to discuss. Any comment on this agenda? Anybody wants to put in? No? So okay, Damian? You need to stay in the pink square, apparently.
So hello, as Luigi said, we will present now for about 10 minutes the yet again information about the Lisp thread document. According to the mailing list discussion, it seems that we are pretty okay with the first part of the document, which means which is about explaining the different threads and the thread model that is used. So is there anything more that could be added? If there is someone in the room willing to say, no, I'm not agreeing with what is in the document for now, you could go to the mic now. Okay, next slide then. Since last time we had two updates. The first one, the version 11, is mostly editorial polishing, so small typos here and there and clarification in the terms, and also a few clarification here and there, but very little details. Then after we had the version 12. So again, we put some polishing in the editorial, and we addressed the general comments put in the mailing list. But the most important is we added a new section, which is about the mitigation, about the thread, because for now we limited the document to the different threads, the thread model, what can happen potentially to Lisp, and then to respect the charter, we also have to provide mitigation, and this is the main purpose of this version 12. Next section, next please. So the text. So the mitigation, the first observation is that by being very rigorous in how you will deploy and configure your network with Lisp, you can already mitigate most of the threads that are presented in the document. If you are not careful, of course, you can cause a lot of problems, but if you are careful, it works pretty well. First, if you put the rate limitation as it's specified in the specifications, and different filters that are common in any configuration, not just Lisp, but typically you filter what kind of traffic is allowed to come or not, then doing that really helps a lot to mitigate the different risks. Also, you have to be very careful about how the configuration is verified, to be sure you don't try to advertise a prefix that is bigger, to register, sorry, a prefix that is much bigger than the others. So if you are really careful on what you are doing, it helps a lot also. The very basic, the common usage in security is to activate only the features you need. So many features in Lisp have been proposed, but most of them are for optimization and are not specially required in a non-trustable environment like the internet. So in data centers or in enterprise network, they are really useful and you don't have security problem, but in the internet you don't really need them. So you can safely deactivate them. Like for example, LSB, you can live without them. It might be a bit slower to detect the problem, but if you are afraid of security problem, you can deactivate. It will not cause any, Lisp will continue to work. Next slide, please. So also, the control plane proposed already authentication. And our recommendation here is to, for the mitigation, is really to, whenever it's possible, use the authentication mechanisms that are proposed. They are there. For example, you can authenticate map request, map reply, and map register. This is in the specification in RC 6830 and 6833, but also in LispSec. So LispSec it's not yet in Haskell, so let's make it in Haskell, so it will become RFC as well. But if you use this authentication mechanism proposed in these three documents, you can authenticate completely map request, map reply, and map register. So in this case, you are sure that you will not have kind of wrong answers. It does not prevent people to lie when they are a fake ETR can still be extensively lie, but you are sure that it will not be modified. And also, the other mitigation that is really essential is for every message that you will exchange within the mapping system, so not from the, let's say, the data plane to the control plane, but really inside the mapping system, like inside the Lisp DDT, you should also use authentication all the time, and that's a good point that Lisp DDT proposes it. So you can have, and we really propose that it must be used that way, and so you are safe in an environment that is not trustable. So it's already available in the specification, so no need to change anything, just use the features that are proposed. This is important, so we show here that, okay, there is threats, but it's possible to mitigate them by using correctly the specifications. And also there is something interesting that I rediscovered recently in RFC 6830, is that there is the authentication data field that is specified in the document. Actually, it just specified how to encode it. There is a field for authentication data, but it's not explained what to do with. But the good part is, so if you want to add authentication that is not yet available, you don't need to change the packet format. It's already there. So you can use the authentication data. So now we just have to propose mechanism to use it. But again, it does not require any change in the protocol by itself. It's just the way to use this data that is there. Because the field is there, but not used. Next slide, please. And also, and that was kind of a long discussion on the mailing list with Ron, among others. We have to find ways to slow down the attacks. So of course you will always have attacks, that's inevitable, but if you make the attacks being slow to mount, then people will not really make them. It's too slow and it's too expensive. And something that is really important is the attacks that would be led by triggering control plane events from the data plane. So controlling mapping system messages or generating control plane operation in the router. So by doing some form of rate limitation, you can really reduce the risk of this. So basically what you have to make sure is, because the data plane is faster than the control plane, if you have something coming, you have to be sure that it will not be faster than the control plane, even if it goes really fast from the data plane. So you slow down by using rate limitation. Next slide. So something also very, very important is to always verify the information. So if you keep the different features such as LSB or the reachability bits here and there, it's okay to have them, but you should not use the information as is. Instead, it should be an information saying, okay, I observed that something happened, now I have to verify. So every time you don't solicit an information, but you receive it from the outside, you can use it as a way to start a procedure to verify the information. Of course, if you don't want to have it as a new attack, you have to rate limit it. But again, this is without changing anything from the specification, or everything is there. And something, for example, interesting that I don't put in the slide, but is you can use gleaning actually. In this, there is not a problem. But instead of using gleaning directly, I receive an EID and an airlock, and then I will use the airlock for all packets for this EID. Then instead, you can use this gleaned information only for the flow you have observed. So when you receive a packet, instead of inserting in the cache, instead of inserting EID to airlock, you put flow to airlock. And so every time you will see packets for the flow, you will use this entry, but not for the other, such that you isolate the attack. And that makes for the attacker, the attacker something very difficult to do, because if he wants to carry, he has to generate one packet per flow he wants to destroy. So that's not very easy for the attacker to do that, and not worth doing. Next slide, please. So as every 4 months, can we go to the last call this time? Well, not yet. Or we see again in 4 months to ask for the last call.
Is anybody that has any comments on the second part of this document, so on the mitigation? That's the important part we should discuss. Don't be shy, guys.
Ron Bonica, Juniper Networks. Much improved document. There are a couple of global comments. When you introduce a mitigation like a rate limiter, it might be interesting to take a second pass through and see if the mitigation itself isn't a target for a new attack. For instance, once you rate limit a resource, if the attacker hits the rate limit, is the resource now available to the legitimate user?
To answer this particular question, it's already in the trade model. It's already explained that the mitigation can sometimes be a problem, but then again, it does not need to change the trade model, because, okay, you have rate limitation, so it means that it will slow down, it corresponds maybe to a DOS, and then it's already explained in the document, but yeah.
Okay, got that. And the second one was kind of new to me. The idea of gleaning information, but what you glean is accurate only per flow. So that means you're keeping per flow state on the router?
So gleaning is an optimization in terms to be faster. So what you can say is, I put a little table, it just to be a bit faster, is to avoid to have to send a request. So you can put a table at whatever size you want, depending on how much you are ready to pay for this optimization, and then put kind of a LRU to keep it or whatever. So it's just an optimization, so it will not prevent the system to work. It's just to say, okay, I don't want to to pollute. It's a way to not pollute your real map cache. Then you can say I put a little space, maybe few hundreds of entries, it's enough. Okay, if I'm attacked, okay, it will fall back to the same as not having cleaning at all. So, but it's better than deactivating completely. You can say, okay, in normal condition, it will work better than without cleaning. If I'm attacked, then I fall back to the condition as if I had deactivated cleaning. Because the table is full, and then, okay, you cannot do anything, the table is full, so you don't clean, and instead you will send a map request when you need.
So there is general state that doesn't take advantage of cleaning, and then there's extra state that does take advantage of cleaning on a per flow basis.
Yeah.
Question mark. Okay,
Yes.
thanks.
And again, so it's like LSB or the reachability bits in the different map replies. Those are kind of optimization to be faster. This works pretty well in trustable environments, so I really encourage to use them in trustable environment. When it's not trustable environment and you say, okay, performance is not my question number one, but I still, if possible, I want to be able to use it, then, okay, you use or you don't use, but at your own risk. And for example, the cleaning, you can say, okay, I'm ready to do it, but I limit the risk, so I don't clean completely, I clean only a part, and I will see what's happening.
Daryl Lewis again. A couple of comments. First, on the whole extra table gleaning optimization, cool ideas, there's an endless amount of those. And I think the traceroute support is another example of that kind of an optimization that can use extra state. That if the small table fills up and you know, that's just the way it goes. It's not an overall detriment to the system. But the larger comment that I have is I think this document is at a point of diminishing returns when it comes to providing additional techniques or ideas for mitigation, and that I think it's ready for publication.
So first I have a comment on this discussion on the gleaning and flow state, etc. This is not in the current document, right?
What,
This
the gleaning?
flow, no, the flow state that you are
It's
talking.
not written, but there is a reference to a document that explains how to do. And
Yeah, but my point is that this is kind of implementation dependent, and maybe we should not try to explore how to solve the security threats through implementation dependent issues. So we have a general document, and we should stick with that. Then this is my personal opinion on that.
I agree with that. This is why it's just the reference to the document that explains it, and not how to make it written in the draft directly.
Second point comes to the question whether or not this document is ready to be handed over to the AD, right? So let's check the room as usual, and if you think this document is ready for working group last call, please now. Thank you. Now, if there are people that disagree with this and think that the document is not yet ready to go for a working group last call, please now. Very well. For the minute takers, there seems to be consensus in the room for for working group last call. We take it to the mailing list as usual. Okay.
There was one additional supportive hum from the Jabber.
Excellent. Thank you. So let's go to the next presentation.
So I had to make 2 advertisements today, so I have to decapsulate myself. Sorry.
Okay, I'm the other head.
So, and that goes well because now we'll talk about the impact. And before that, so there is the Lisp lab project that Luigi will probably talk during the overflow. If you want to deploy Lisp, there is an infrastructure now that is much more advanced than the Lisp 4.net network that is available, where you can connect your system and try with different implementations that are there. He will talk about that after. But let's now talk about the Lisp impact document. Next slide, please. So 2 versions between last time and now, the version 0, that is actually exactly the same as the version before, just that we became working group document, so we had to change the name to be compliant with the name. And it was actually adopted after 8 versions since October 2012, so it's not really a 0 version, it's just the change of name. Next slide, please. And so for version 0.1, as usual, we made some editorial polishing, and we updated some references. Brian asked for a few numbers, for additional numbers in the document in section 3, and we added some numbers. Actually, the only number we had was the size of the edge of the internet at the time of the writing, as to say, because otherwise there is already numbers on the number. So here I think we addressed this comment. And also we added here and there small commands that were responding to the different comments we had during the last meeting and on the mailing list and discussion with the people to clarify the text for what was unclear yet. And we extended the discussion on interdomain multicast to add a reference to signal-free multicast. This is the update of version 0.1. So next slide, please. So it's already in last call, but then we are now in the procedure of last call. And if you have comments that would be, or if you have deployments, or if you have seen some impact on using Lisp or non-using Lisp, but because of people using Lisp, it would be really nice to share this on the mailing list so we could add if there is something you want to say more.
Yes, as Damian said, this document is already in working group last call. So so far nobody disagreed on this situation on the mailing list. Do you have any comment on the document itself that you want to share? Any? Okay, seems not. So let's check if you guys you agree that to go further and hand it over to the AD. So do you guys agree that the document is ready and we can close with consensus the working group last call in few days? I don't remember exactly when is the deadline. If you agree on this, please hum now. Thank you. And now, if anybody disagrees, thinks that the document needs more work and is something that needs to be better explained, or any comments, please hum now. Okay. For the minute takers, seems that there is consensus in the room.
And one positive on the jabber.
Again, consensus to move the document forward. Okay. Yeah. Thank you. And now it's Dino time. Dino, now we have a small issue because usually we are supposed to stand there, but the cable was being screwed.
You can operate.
I like.
Maybe it's this one. Oh, I got the wrong one. Hold on. Dongles everywhere, huh? There you are.
Okay, so for every decapsulator, there has to be an encapsulator. We kind of did it in the wrong order, so we should encapsulate first.
Okay. You get very strange results when you go first.
Hopefully our large keep Okay.
You've got to be in the pink box.
Big box.
Oh, pink box. So, yeah.
There's a camera somewhere that's looking at the pink box.
Okay, I'm going to talk about the first version of this working group document, and next slide will basically tell you the chronology and history of this. Next slide, just a tap. Yeah. So we presented these ideas at the Lisp Working Group in Vancouver. That was fall 2013. Joel had a really good suggestion on, since we're routing guys, we don't know very much about security, let's go to the SAG and have them be part of the solution early on. So we did a presentation to the SAG at that same IETF in fall 2013. Then we built a 0-0 individual submission draft and presented that in spring of 2014. I did, Lispers.net did an implementation of that in the spring of 2014. And then what we learned from implementation, we put into the -01 individual submission. And we tried to present those findings in Toronto, but we ran out of agenda time, so I got some agenda time in Honolulu in fall of last year to present that. And it was decided then that we would make it a working group document and work on the things that we need to work on. So we created the working group draft, this -00 that I'm going to talk about today, in January of this year. Next. So the basic design overview, we could describe the functionality in one slide. We're basically creating, encrypting the data stream from the ITR that encapsulates the data to the ETR that decapsulates the data. And what we're doing is a Diffie-Hellman exchange and the map request, map reply exchange. So we exchange keys at that point, public keys at that point. We get the locator information back at the ITR in the map reply, and we also get the public key of the other side. We're able to both compute a shared secret that is not transmitted over the network, and that's used as encryption identified by a key ID. So the keys are not stored anywhere. It's very much like SSL/TLS. The keys are ephemeral. We can negotiate 3 keys and identify them in the encapsulation header, so we could rekey on the fly without any problem. And basically the idea is that the ITR will encrypt the payload, then encapsulate it. The ETR will decap, strip the outer header that is, and then decrypt the data and pass it on. We can do rekeying as part of our load probing, so if an ITR wants to probe the ETR to see if the reachability is up, it could also request a rekey. And so that could happen at the same time. So you can use a couple keys for data transfer and then rekey some other keys, and then once the exchange happens, you can start using the new keys. And we have some comments from guys on the list about how well that was written and done. Next slide. So the discussions from January 2015 on the list were, next step please. Working group the working group should discuss security-specific encapsulation format details. This was a comment from Fabio saying that maybe since we're looking at Lisp GP as an encapsulation format, that we can do a more general encoding, because what's happening now is that the last 2 bits of the flags field is being used for 4 values, 1 value meaning no encryption, and the other 3 values meaning key IDs 1 through 3 can be used, and therefore defines that the payload is encrypted versus in plain text. Next. The working group needs to detail out the interaction with ListSec and ListDDTSec to cover man-in-the-middle of attacks. So what happens if there's a man in the middle that tries to be in the middle of this map request, map reply exchange? What do we have to do? And we kept claiming on the mailing list, which I think true, is that ListSec will authenticate the source so you know you're talking to the real ETR versus a spoofed ETR. But we need to, it was questioned by many people that we need to make that more clear in either this specification or in these other security specifications. Next. Doing elliptic curve Diffie-Hellman will cause MTU problems because we'd be packing 3 large keys in a map request and map reply. This is a typical problem the security guys have seen, so they said there's better algorithms and things, research we have to do to decide if we should use elliptic curve. Elliptic curve helps you on CPU, but it costs you in packet size. So the question is what extent of security, very subjective question, or a subjective answer to this question of how strong does the security have to be? I tried to make some commentary to the commenter saying that we believe there will be application level encryption that's also happening, and this is just another layer. So not clear if this has to be as strong as application level encryption. But the security people in the audience might have opinions on this. Next bullet. So Watson Ladd, he commented on some of this stuff, and he was claimed as a crypto expert. So we got another view. Brian's been helping us among other people. Brian Weiss is in the audience. But he said we should actually reduce the number of options that we have, in other words, the different types of ciphers and keys. It turns out that this working group decided that putting options in and having a registry and a group ID for more options was a good idea. So his comment and our working group current status is in conflict. Next. Other Watson comments, he thought the rekeying logic was good. He said that it was certain that you knew when the key, as long as the map request got to the ETR and the map reply was returned, and you knew that that was reliable via using a nonce, that exchange was reliable, and so rekeying could work even during data exchange. Of course, you can't rekey the stuff that you're using, so it's up to the ITR to know to not use that key if he's in this rekeying state, and he knows that the rekeying state is complete when the map reply is returned. And the map reply that is returned with ListSec where the signature is verified. He wanted the draft to discuss security structure of the mapping database. That was more of his concern than data plane security. He wanted to know that all the control plane machinery was actually secure so there was these man-in-the-middle attacks would not happen. So it was more of a general architectural comment about Lisp security. So, these are things that the working group could work on as part of this draft or just as a general item. I don't know what the chairs feel about that, but that was his commentary. And then one other thing, I guess Brian apologized before the meeting, but he's on the hook to help review this in grave detail. And so we're going to spend some time this week working through it. Anybody else is welcome to join us. If you want to be part of it, just send me an email and we can set up a time this week. Next slide. Implementation to-do list. So I've done an implementation of this draft. I've done multiple keys, but I didn't do dynamic rekeying. So on key-related testing, I'd like to start testing larger keys, use elliptic curve as the cipher, or as the type of exchange, and then use other ciphers just to see what the CPU performance is. My implementation is purely a software implementation, so I could measure these sorts of things. We could decide what's hard and what's easy for hardware implementations ultimately. Do more rekeying logic, I'd like to try that in more corner cases. And I would like to test this with multi-feature testing. That is, what about the ITR talking to an RTR for either service chaining or NFV, or for including NAT traversal? Do we want this stuff to work through NATs? And the obvious answer is yes, we need to. Should we test it with multicast packets? When we take multicast packets and unicast encapsulate them, each replicated packet can be have a separate key, and so you could have a Diffie-Hellman exchange for each one. And we need to test it better with ListSec. So those are things that I'm planning on doing. And of course, it would be nice if other implementers wanted to try this out as well. I'd be glad to work with people that wanted to do some interoperability testing. So I want to make a call for implementers to, if there's anybody interested in doing an implementation. And the most popular open source platform we have for Lisp right now is ListMob. So if there's any ListMobbers out there that want to do this, that would be wonderful. Looking at Alberto specifically. But anyways, next slide. That's it. Questions, comments? Ron.
Hi. ¿Cómo está? Ron Bonica, Juniper. A couple of questions to keep the party lively. The purpose of this draft is to prevent pervasive monitoring. It's about privacy.
Yes.
It's not about authentication.
Correct.
Yeah, exactly. That was the answer to that.
So all the words I said about authentication was to make sure that we could authenticate the map reply so the key exchange is secure.
Okay, but that's not this draft. That's
what we're saying is that there's no man in the middle of attack that can get in the middle of the Diffie-Hellman exchange because ListSec will help us there.
Oh yeah,
that's the other draft.
Well, that's what Diffie-Hellman's all about too. You can watch the whole exchange and still not know what the keys are because
Right.
Diffie-Hellman protects it from that. Okay.
No, that's not the problem.
Yeah.
Here, let me be very specific. I'm the ITR, you're the ETR.
Yeah.
I'm sending a map request. I expect a map reply from you. Okay. What happens is, on the path to the map request, Brian intercepts it. He sends a map reply back to me, and I get a public key. I think I'm talking.
You get a session that I can't play in.
No, he
No,
has a
he has,
separate session.
he established a secret key with me.
Yeah, you two guys.
Yeah, right. And what's happening is I'm actually, nobody will be able to monitor the session between me, he and I, but it's between me and the criminal, right? You know, I want to make sure that I'm getting the Mapify from whom I'm getting it from, and that's what ListSec solves, right?
Okay. Good stuff.
Got it? Okay.
Any other comment or question? Okay, let's move to the next.
Okay, so we're going to talk about signal-free multicast. And this work has been really fun, and it's been going along pretty well. And we had a good talk with Daryl and the Cisco guys at the last IETF about some service provider requirements. So we tried to put this in here. So I'll give you an update on the draft. Yeah. So the initial idea of this for signal-free multicast was presented in Berlin, so summer 2 years ago, almost becoming 2 years. Next. And then I wrote a -00 draft and was inspired by Sharon from Context Stream about how he needed some simple multicast solutions to be solvable on a small scale. So we said head-end replication might be something that's really easy to use. And he wanted simple mechanisms with less protocols. So this was the motivation for the design. So in the -00 was published in February 2004, presented in London in March 2014. That's 2004. 2004. February was published, and March we presented in Lisp Working Group. Next. So I did an implementation based on the -00 draft, and of course, lessons learned from implementation always is the case, and we reflected that in the -01 draft and presented that in June last year. Next. And then we talked with the guys from UPC, especially Florin and Victor Moreno, who was involved in the Lisp replication engineering draft. How do we control head-end replication by putting RTRs in the middle of the network that can control head-end replication? And it turns out that Lisp RE has signaling mechanisms, and we thought, could we bring the signal-free mechanisms to the RE draft? And that's what went into the -02. Next. So just to give you a quick overview, basically when receivers come up in these domains, like in the B and the D domain over there, they basically register the S, Gs that are being joined in the RLOC list. And so you see that this S, G exists in the mapping database with RLOC Bs and RLOC Ds in it. So when a packet from S hits A, ITR, the ITR sends a request for the S, G, knows who to replicate to, takes the multicast packet, and replicates it in unicast and sends it to each one. That's signal-free multicast. It's meaning that there's no tree building mechanisms on the overlay. If there's any tree building mechanisms at the site, so be it, they don't have to change. But the whole idea here is that we're unicast replicating over the top, and we're using the mapping database to find out the group membership. Next. Okay, so the problem with signal-free multicast is since we're taking a multicast stream and sending it to multiple sites, we're replicating very close to the source. And that turns out to be a bandwidth problem close to the source. So we have a head-end replication problem. For a small number of replications, you just deal with it. But as it grows, you want to be able to solve it. That's why we introduced replication engineering, is so we could send one stream into the network and have a service provider worry about how replication engineering is done throughout the network. But signal-free multicast certainly brings a lot of benefits because it's extremely simple and easy to understand. Basically, what I just showed you on the last slide is exactly the way it works. There's no hidden gotchas. It's as simple as that. Hopefully everybody understood that slide. But it comes at a cost of this head-end replication. So we want to try to simplify Lisp RE because right now it's specified by using PIM to actually signal the trees, or using map request signaling was another draft that I did. And I'm calling those signaling mechanisms where signal-free multicast says use the mapping database. Next. So Lisp RE was documented in -06. provides a layered overlay topology for replication. And that tells you the entire layered topology that can be used for replication, but usually a subset of that topology is used to build an acyclic tree so you don't deliver duplicates and you reach all the members. Lisp RE states that the signaling mechanisms are 6831, which is the PIM over the top, or the MR signaling, like I said. Let's show how the mapping database could possibly be used for the signaling in the RE topology. Next. So this is the problem. This is the problem we want to avoid, is this is typically 1 or 2 links into the network, and we're duplicating packets over that link and wasting bandwidth. So that's what happens today for default signal-free multicast, is because we have this guy do the replication. Next. In a Lisp RE framework, next, you build this layer topology, and these are re-encapsulating tunnel routers that are in the core, supported by well, I'm not going to say if it's in the underlay or the overlay, but what happens is encapsulation that happens from there to there, and there's lots of IP hops there, and there's lots of IP hops or MPLS hops in the middle. But this is a layer 0 topology. This is the layer 0 part of the topology, and this is layer 1, which means this guy encapsulates this layer, that layer encapsulates to the next layer, that last layer encapsulates to the ETRs that are at the site. Next. And so that's the total topology, but if you actually want to forward a packet, you don't want to send it to 2 places, and then 2 places, and then 4 places, or you get all these duplicates. So you have to build a subset tree that's on this topology, and the way it's done today with RE is using these signaling mechanisms. So we're trying to look at how can we do this with a signal-free mechanism. Next. So what we're proposing is that you put an S prefix, G prefix in the mapping database that describes this entire topology at these different layers. We have an LCAP that's called RLE, Replication List Entry, that describes these different layers and levels. Go ahead, next. So what happens is, what we're proposing for the signal-free part of it is that you have the entire S prefix, G prefix of the layer topology, but we have 2 types of formats for a specific S comma G. This is an S in G that's more specific from this S and this G. Okay, that's what an IGMPv3 receiver would join. That's what a source would use in its packet for the addresses. And a complete entry means that the mapping system would return back the subset topology. Notice A, C, and D. A, C, and D, not the entire one, as well as all the receiver domains. Okay, so what the ITR can do here, that it has both options. It actually can replicate just to the L0, and the L0 guy then replicates to 2, and each C and D replicate to the 2 ETRs. Okay, this is what can be done. Now, it turns out that the ITR and RTRA are RLO probing because this guy's testing this path. If that path does go down, the ITR always has the opportunity to send directly to the ETRs and go way over the top, and still have that HER problem. Okay. So now the next format is a filtered format. Go ahead, Tap. Okay, so what I was saying here is this is the entry that's in the mapping database. This is the entry that's actually cached in the ITR. Hit Tap again. And then the ITR decides to encapsulate to this guy only, and then the replication happens. Okay, Tap. So the filtered format basically says that the mapping database still contains the information as in the complete format, but what gets returned to the ITR is only the information that the mapping system wants the ITR to do. So the mapping system or the map servers decide how the ITR is going to do replication. And this is useful because this may be a customer of a service provider, and the service provider might want to decide how data comes into its network, and it wants to control the replication vision tree. Okay. And so, tap again, Luigi. And so the same thing happens as ITR just encapsulates to L0. But as you can imagine, there's all kinds of options. You know, this guy could replicate to both of them. This guy could replicate to 1 that replicates to 4. There's all kinds of options, but it's controlled by the mapping system, and the mapping service provider that probably has a good relationship with the data plane service provider would need to get this right. So it's a way of programming that. Go ahead, Joel.
Quick question from Joel Halpern. Is this restricted to exactly one or two layers, or can it be multiple layers?
It can go up to 128 layers is the number.
Because the format doesn't make it clear how the intermediate layers would know which one was responsible
Yeah.
for forwarding to.
Can you go back to the slide? Just swipe towards yourself. You did it, yeah. So,
If there was a layer 2, I don't know how.
So what happens is, Joel asked a very important question, and this is the question. When the packet gets encapsulated to the RTI, he strips off the outer header and now wants to encapsulate. What does it do? Well, it doesn't look up for S, G, because that's what's in the inner header. And it sees this sort of stuff here. Well, it sees that it's at this part, right? Now the question is, should it encapsulate to C only, or should it encapsulate to C or D? That's the question. And the mapping system can decide that because we also have an LCAP format called ELPs, explicit locators. And if I have A, B, C in this ELP, it means A sends to B, sends to C. Now, if this ELP contains A, and at the B level, there's an RLE, which contains B and B prime, then A replicates the B and B prime, and B prime then would just send to C. Okay? The mapping system would have to decide which one sends to C.
The question I was trying to get at was what the format of the information was delivered such that, because if there's a layer 2, do you interleave the layer 2s after the layer 1s to say this layer 1 is responsible for sending to these layer 2s?
Yes.
I wasn't sure how the topology was represented in this, if it's more than.
When the map request comes from the RTRs, the map server knows who's requesting it, and they know which layer, and then it responds back on which ones it wants to do. Okay?
Okay.
So the way we currently have the design is we want to put the complete information here because we know the mapping system and the service provider may not be the same organization, and the complete information may be useful in somewhere far from the mapping system versus everybody's asking the same question but getting different answers, and those different answers are in different places of the network. Go ahead, Sharon.
Hey, Sharon, Context Stream. So let me try to describe the same thing in like a flat, no layers way, and maybe I understood it, maybe not. So for small capacity application layer multicast, we know it's just the mapping. You ask for the channel, you get it.
Yep.
Replication is not a problem. For heavy traffic, we can describe it maybe, if I understand it correctly, NFV style, where again, if you want the channel, you look in the mapping system, what function replicates that channel,
Yes.
and you register. Same goes for that function. If it needs that channel, because it also looks for the resources, so it becomes layerless. So it's all about orchestrating enough functions to multicast that channel, and depending on demand, and then scaling it down. There is really no layers.
Yeah, good point. So the way I like to think of it designs is I like to look at the maximum scalability and see if I can solve the hard problems, and then if they scale down, they should. If I did a good job scaling it up, they should scale down. If you wait for the next slide, it's basically the requirement that Daryl has fed from the service providers on probably what will be most likely be deployed. This is a complex case.
Yes,
Okay.
but the scale out would be, let's say this row wants a channel, and I'm a function, the register for me, but because they look for me in the mapping system. But if I'm too busy to replicate to them, they will look for somebody else.
Right.
When I allocate another channel replicator,
Right.
then he will be able to serve the additional people, but he will also need to find somebody to get the channel in the first place.
Right.
So this way, the fan out happens. This is assuming an overlay we don't care about.
Yeah.
Okay.
So
the only consideration usually when you look for a function to do anything for you is how busy it is, and then what's the round trip delay from it, and then you choose the best one.
Florid has looked at the capacity issue, and the thing that we have is since the map server, the mapping system, is answering the questions, it needs to know about the load of these replicators that it's telling to use.
That's true for every.
That's subject for further study. Should we
for
use
every function.
a polling? Yeah, right. So yeah, it could very much be load balancing rate control. Right? And DOS attack control too, because people have asked, well, what if one's being abused versus the other? Okay, next slide, it should be the last slide. One more. So we think this is going to be the popular deployment where really the ITRs have to be pretty dumb. They just have to forward into the service provider, and the service provider will take care of the replication. And so maybe it starts off with 1 or 2 replicators, and if a service provider decides 4 is too much for fan out, or maybe those 4 fan outs are going out 4 physical links and it's not using up bandwidth, that is simply switching capacity, not bandwidth capacity that it's using. But the service provider itself can decide what to do here. But the key here is that the ITR is very simple, where you could use SDN and just put a default entry here that always encapsulates the RTI. Or if the hit next, I think I have stuff that says it. Yeah, so the ITR basically just has an SCOM, but just says encapsulate to one place. That ITR most likely will be behind a NAT. And if it's doing NAT traversal, it's encapsulating to that RTR for all packets. So nothing really has to be done to the RTI. Now the packet gets encapsulated to the RTR. The RTR just does this lookup, and it's just signal-free multicast. So what we showed you in the very first part of the diagram where the ITR sent to all the ETRs, we just moved that functionality there, and we let this guy default into this path. And we think that's a simple case for the service providers. I don't know, Daryl, what you think, but this is the way I understood the requirement. Start simple and then scale out later. Comments? Questions?
Lucy, could you go back one more slide?
Name?
Lucy Young from Huawei. Yeah, so from the RTR, the package getting multicast package get encapsulated to this RTR in the middle. Replicator.
The multicast packet comes to the ITR.
Right.
If it's encapsulated in unicast, travels unicast there. It strips off the unicast header, interrogates the multicast packet to do this lookup, and then encapsulates the unicast to all those 4 destinations.
So from this the RTR to this replicator, it's still Lisp package? The unit encapsulation with the Lisp? Okay.
Everything in white is going from this locator to this locator, Lisp encapsulated. Yes.
Okay. But from this one to fan out, it's
Lisp encapsulated.
But could be multicast package, as you said.
No, you're not understanding. This guy sends out a packet to 224.111. It makes its way here.
Yeah.
This guy says, I'm going to encapsulate it to the IP address of this. So it's a multicast packet with a unicast header, goes to RTR. RTR says, I'm that unicast address with outer destination. I decapsulate. I look inside the process packet. There's an SNG in the destination address, source and destination address of the inner packet. I do this lookup. These are the unicast IP addresses of those ETRs. So what I'll do is I'll make a copy, I'll encapsulate it and send it to our local there. I'll make another copy and encapsulate it to the our local there. So what's flowing over here are unicast packets.
Unicast too. So this is completely independent of this underlying network multicast. No those address at all.
This is the capital I internet across multiple service providers.
So only overlay multicast address needed. The packet never have underlay. Okay, that's what I'm saying.
But that's not the uniqueness of the proposal. The uniqueness of the proposal is that the information on where to send the packets are put in the mapping database. Because 6831 also said that if you use PIM signaling, you could put a unicast address as the outer address. But in 6831, we said do multicast and multicast as. So if this part of the network did multicast, this guy could just send up one packet and they would receive it because it's multicast capable.
Vina Armagonska.
Hi, Vina.
Hi. Do you have a packet format? Are you planning to store these in the ELP format, extending that, or is it completely separate?
Oh, it's RLE, the replication list entry.
Okay.
Yeah.
And then
This is one EID record with one RLOC record, and the RLOC record is an LCAP that's RLE file.
Okay.
And it has that list. And RLE, the difference between ELP and RLE means send it to all of them. ELP means send it to the next one. Right? So it's a set versus a.
So when you say send it
change.
to all of them, meaning that the mapping service will return only, let's say you had.
No, in this case, it returns those 4.
Right, but if,
Oh,
it returns only RTR L0 to ITR, right?
Yeah, yeah.
So the ITR gets only one locator.
Oh, but I'm claiming that the ITR will not do an S, G lookup here, because this will already be populated. See, when this thing comes up and realizes it's not behind a NAT, as you said, and as you know, you're the author of the NAT draft, that it will put in a 0/0 map cache entry.
Right.
It should maybe be a 0/0, comma 0/0 to be S and G because it's a multi-cache backup. So it's going to match on that. Never have to send a map request. Just like Lisp mod does it by default. Being behind Lisp. And so it'll always have that IP address as this. So it never has to even consult the mapping system.
Okay. But in the general case, the mapping system will have the mappings. The hierarchy of the layers that you define for the RTRs are separated in the mapping entries, and then the mapping system will always return only the entry that they're requesting no
Yeah,
ask for.
it can do that. We need to specify more clearly if it should do that. Yeah.
Okay.
Yeah. Thanks.
Vigo from Huawei. From my point of view, the middle node of RTR is the centralized replication node. Yeah.
Yes.
The packet from RTR to middle node is unicast.
Yes.
Yeah. And the middle RTR to the egress GR is multicast or unicast?
Unicast.
Only unicast.
That was Lucy's question.
Oh, okay.
Unicast.
Yeah. I think the middle node RTR should consider a redundancy problem issue. Yeah. If you have only one RTR, if the node fails, whole network multicast
we're not
doesn't
proposing.
work.
We're not
Yeah.
proposing there's one, and with NAT traversal, you can ask the map server, and the map server gives you a list of RTRs, and you can decide which ones you use. So there can be hundreds of ITRs here encapsulating to different RTRs.
Okay.
Yeah. No single point of failure. We don't do these things here.
Okay. Thanks.
In slideware, it always works perfectly.
Yeah.
The single points of failures happen during implementation.
Yeah.
Always.
And that's why the draft number is so high.
Yeah. So, Daryl with Cisco again. I wanted to kind of maybe restate the problem case that engendered this specific design. And the requirement was simply that the ITR was normally doing head-end replication. The ITR had a known fixed capacity for this head-end replication. The ITR wanted to shift that capacity, the function of replication to another device in a non-signaled, statically configured way. That's it.
Right.
So I think that we'll talk about this offline, Dino, and resolve it. But I think another way to consider this, instead of the RTR being this blue box that's in the center of the topology, that it's kind of different from all the other boxes, the ITR could be considered in this picture green and adjacent. The RTR could be considered colored green and adjacent to the ITR. So he's a member of the topology. It's just like any other site. He just happens to be the one that's.
Where's he located though?
It could be right next. Could be a virtual machine next to the ITR.
But you don't want to head and replicate.
That's what we're doing here. Is just
No. The whole question is, are you saying it's here or are you saying it's there?
It could be either.
Yeah. But if it's here, then you have head-end replication problems.
No, I mean you had.
That's all I'm saying.
Okay, but the point here is not the bandwidth issue. The point is the computational capacity of replication on a single device. We want to add more capacity to replication. That's the point.
If you put another box solution that's attached down here, and it just does the default single tree multicast, you're done.
It could be, or it could be located somewhere else. But
you got to be specific on where, because we have to look.
It probably will not be one hop away. I probably want to use a unicast overlay to get to this device. But what I'm saying is that you're assuming a provider-customer relationship here that may not be the case.
Okay, I just want to know, what is this demarc point then? And is this a sensitive link? That's what the crux of the issue is. Because yes, this functionality could be put anywhere, but if you put it on the side of this sensitive link or switching performance, then you have to talk about each combination. so I understand what you're saying.
Okay. Well, like I said, we'll probably talk about it more. I just wanted to kind of poke at this, saying that there's some assumptions here about a provider-customer relationship.
Oh,
that it doesn't necessarily follow.
No.
Anup Ganwani from Dell. The question that I had was about the levels of these RTRs. You said
You want to
can
go
have
back? You want to go back a couple slides?
Yeah, okay. So you mentioned there can be up to 128 of these levels, right?
Yeah, worst case.
Worst case. So even with this simple example like L0, L1, does the level of an RTR, is that relative to a given ITR and set of ETRs, or?
It's relative to a given RLE entry. And this RLE entry, this guy knows that he should not replicate to him because he's at the same level that he's downstream. So it just created the levels. That's all it did. See, today,
So
what happens today with RE is that a PIM join would come from here to the level 1 guy. And then the level 1 guy would say, I have a choice of using these two because that's what's in the RLE. So I'm going to pick one to build an acyclic tree. So since it's signal, basically the RTR gets a PIM join, and then that he knows he needs to forward to him. And then he does the same thing back here. So all the white lines are created because of the signaling mechanism. Now that we don't have the signaling mechanism, the decision of the acyclic tree is built by the map server and returned back to the nodes for them to obey. Okay? This would be really bad if this ITR also replicated here, right?
So the leveling is all, it's built by the mapping database
for
a given SG entry.
There could be a provisioning system or something that decides how to do the replication engineering that actually builds this and writes a mapping entry. Writes this RLOC record for this set of prefixes and groups. Yeah.
Right.
Mm-hmm.
Okay. And the second question was, if you've experimented with this, do you have any thoughts on like how many, up to how many ETRs can one RTR comfortably replicate to?
Well, I could tell you the one case we started with, which was interesting. We had a multicast source sitting at a university behind a NAT, and because of NAT traversal, it was just unicast replicating here, and that RTR was actually doing the lookup and just replicating to 4. It was 4 places. 2 places were in public spaces, and 2 other places were behind NATs. So the 2 receivers were behind NATs. So we tried a replication of 4, and it was done in software, of course, on a server that was sitting in a G-Cloud, Google Compute Engine VM.
Okay. All right, thanks.
Yeah.
I have a question related. So who is going to decide what it will be the tree, the distribution tree? Because you just said a map server can decide, but these different ETRs are connected or dependent from different map servers.
Yes, you're truly right. And this was one of the initial problems we saw with Signal Free, is that since they are all joining or registering for an S, G, and the S, G's are if they're typically, this is a bug what I'm saying by the way, if they're typically in different map servers, how do you merge them? Because the way it works today is that if this guy has the first receiver, he goes to map server 1 and says, I'm registering S, G. If this guy's the second one, he goes to the same map server, that registration is merged in. But if it's 2 different map servers, how can it get merged in? So I thought this was a bug. It's really not a bug, because if we're using DDT, why are the 2 leaves disconnected? It's like having a map server registering 2 different prefixes in different parts of the DDT tree. It's kind of broken. It all will fall to the same map server or a pair of map servers that are in the same set. That's the key. So if you think of DDT, a map request goes to DDT, what it's going to do, it's going to follow the delegation of the group. And so the referrals will come back, and the map request will literally come down to this point. And then after it exhausted the G bits, then it's going to look at the S prefix or the S bits and come down. So it's then going to find a set of map servers at that leaf. It can't go anywhere else. So by definition, when these ETRs register, they'll register to one or more map servers that are part of the same delegation part of the tree. So therefore, should not be a problem. That's what I was claiming. Do you guys have a reaction to that, or? Why would they be separated, Joel? Because your eyes are sending a message.
But I'm trying to actually follow it because there was a subtlety tucked in there that was interesting. The ETRs are registering with the S, G. So they're not registering with their own address. Sure. They have to register with the map server for the S, G, which is not one they may have a...
With the source, not them. And this is a feature, not a bug. Because when map notifications happen, see, when...
But do they have the security association? Normally, ETRs have a...
Oh, no, they are not registering they're not registering for this guy's EID prefix. That's a different site with a different key. When they want to register S, G, anyone who's allowed to join this set of group will have a specific site entry in the map server with a different authentication key to be able to allow to join.
So to join an S, G group, you're going to have the key for joining. The joining key is going to have to be circulated via out-of-band means. Okay, then the rest works, yes.
Well, no, to be honest, the problem is I have to know all the different map servers that are associated with all the different S's all over the place, right?
Yeah.
And so do I just know that a priori, or do I send a map request for S to the mapping system to learn who the map servers are so that they can register? So these are interesting dynamics, sort of things that we have to deal with. So of course it works really great when you just have a couple map servers and they're not connected with DDT, but DDT makes life really not complicated. It's robust, it makes it scale, but therefore it comes at some cost, right? So. Any questions? This was supposed to be a simple presentation. But maybe next IETF, I'll put DDT in there and show how the whole scenario works. And maybe it'll help better.
And this should be as well in the document.
Work to be done, yes, absolutely.
We go from Huawei. I have a quick question. Can you provide a binary tree solution? Binary tree.
Binary trees, yeah.
Yeah, each ITR is also have attached the multicast source and the receiver.
Yeah. Well, would you set the layers up in power of 2 differences? Would you have this level be 2, next level be 4, next level be 8, each of them just replicate twice? Is that what you're proposing? That's what I thought you meant by binary trees.
The traffic is bidirection.
Okay. Bidirectional traffic is separate. Bidirectional traffic is separate trees.
Yes.
This is single directional, single source specific, multicast. So if you have bidirectional, if you have multiple senders on the same group, you have separate sender specific state. So you have separate sender specific state for each sender on the group. So there's not really one common bidirectional thing. We're solving this for the very common case of single sender to a group.
Let me expand. I'll show you an example of what Joel's trying to say. What you're saying is, what if this guy was also a source for these receivers? How would it work? So what Joel said was, that guy has an ITR. He does a lookup in the mapping database and finds these guys, and he replicates each one of those. That's a separate flow in a unidirectional path. Right? So what happens is, this source sends a packet. This guy is not just an ETR, it's also an ITR. He looks up S, G in the mapping database and gets himself, D, A, B, and C. Well, he's not going to replicate to himself, so he replicates.
No, he would actually get a different answer because the entries people would be registered for him as a source, and there'd be a different entry in the database.
Good point.
It's different. Every sender is a separate set of state. That's either a plus or a minus, depending on how you evaluate these things.
Yeah, every sender is also a receiver. Yeah.
That's a different problem state.
Bidirection tree.
It can, but it's not required to be.
Yeah.
And if each sender is a receiver, this gets expensive. This is for the case where the number of senders on a group is small compared with the number of receivers, typically one. This is, if you're trying for the hypothetical, everybody on the group can send and everybody on the group can receive, this is not the solution you want.
Oh, okay.
It's making the same assumptions as SSL.
Yeah, so you need a separate solution for bidirection.
Right.
Yeah.
Yeah.
If you're trying for EVPN, this is not the answer.
Okay, I see.
Any other questions? Sorry, too much time?
As usual. But I think we are done unless there are more questions. Thank you, Dino. Beto.
Okay, so I will present you the first iteration of the young model we have been working on for Lisp. This has been a collaborative effort between the Cisco guys and us from UPC, from the experience we have implementing Lisp both in Cisco boxes and us in Lismo. Next slide, please. So we think that we need a young model for Lisp because first, there is none, and second, everyone is working on a young model on almost each working group at IETF. And in the same way that we have today RPC for me, eventually we'll need a young RPC when people move from SMMP to network. So next slide, please. For this iteration, we have just focused on the core components with basic features, but allowing for augmentation if you want to extend the model as it is right now. But the idea is to gather feedback from you guys and from other people that have taken a look at the model, and put what people think that this should be in the model, put eventually there. So, next slide. As of now, we have divided the model into two different modules. Since we have this complexity with LCAP, we decided to define all the Lisp address in a different module, basically to put there all the LCAP stuff. It only contains a few LCAP, not all of them, but that allow us to keep all the complexity of the LCAP addresses out of the main Lisp module. Okay, slide. So first, for the slides, I just put a few bits of the models. If you want to take a look at the full model now, actually this morning, I submitted to the IETF because we missed the cutoff, but we allowed us to present even though. But the model is now available, so you can take a look. And here I'm going to skip a lot of stuff, but just to point a few things that I want to highlight for you guys. So, as regarding the Lisp address stuff, where we have put all these LCAP things, what we have done is to create a grouping, as you see there, a Lisp address, that contains the AFI for the address, and if it's IPv4, we have no problem. There's there you can send on the right. If AFI is IPv4, then you just use an IPv4 address from the INET model from the American model. Also, we have the business identity. And when it comes to LCAP, which is the complexity, then we have another grouping. Can you go to the slide? There you see the LCAP addresses. Well, first of all, we have the LCAP type where we enumerate all the different types of LCAPs. Here for this slide, I've chosen to put the AS number aircraft, but you can imagine similar things for the rest. In the model right now, we cover AS number, ELP, and source destination. I believe eventually we'll got all of them there. So again, now if we have an aircraft, we have different containers for each aircraft, and if, for instance, in the example, if it's an AS number, we have aircraft type equals AS number, then the AS number as a lead, and then here's where it comes the tricky thing. We have the address that's usually set at the end of each aircraft. With aircraft, we have a problem that is recursivity. And we have to limit this somehow for Jan. So what we have decided is to use that type simple address to just reduce the redundancy to one level, the recursivity to just one level. Okay, this is you can provide comments on that and feedback. But we need some way to solve LCAF and to put LCAF in a Yang model. So this is a way to do it. So next slide. Now for the main module. First of all, what we have defined is the different logical Lisp entities as features in a module. So you can decide to implement some or one of all of them.
So if I may right here ask a question, Joel Halpern. Have you talked to the Yang doctors about whether, given that these are basically disjoint models, we're better off using feature and if feature, or better off actually building separate modules for each of these 6 things? Because I look at them, they're completely disjoint. So my first reaction was to expect to see 6 modules. Now it works. Using features works. So my real question is, have you guys talked to the Yang experts to say, given there are 2 ways to do this, have you guys figured out which one of these works better in most cases so we can follow common practice rather than inventing practice?
We have not talked about specifically this feature thing, but I think that you raise a very valid point, and we look into that. Yeah.
That's all I can ask.
Okay, so yeah, we now look into these 16 ITR, ETR, proxies, mapster, and knowledge solver, of course. So next slide, please. For the general module, we only use like 2 main groupings to keep the readability of the model. You want to ask something?
Yeah. Quick question on the LCAF, because that recursiveness is really powerful. What's the story with the Yang and recursive? Is just never going to happen, or did you talk to them? It comes up a lot. I mean, it's in a roadmap, or?
I believe that we are not the only ones that have struggled with recursivity on Yang, but
From what I've heard, and I'm not a Yang expert by any means, the conversations there are, no, it is not recursive. You can get what you need other ways. Just do it other ways. It's just the way it is, man.
So yeah, as of now, we can't count for recursivity on Yang, so we need to find a way around to that. So yeah, we only use two groupings on the main module, one for locators and the other for mappings. So, for instance, on the left on locators, you can see that well, we use an interface for Lisp address, and in the Lisp address you see the type aircraft Lisp address that I was talking about that is defined in the other module. Create this way for the stuff. I didn't put all the details in the slide, but you can imagine that, for instance, that also multicast properties and weights are there and so on. And for mapping, just the detail that we have a choice there. If it's a positive mapping, then we use the error defined on the left. If not, we put there the negative multiply action. So next slide. And I put here only the example for ITR configuration to keep this short. Couple of things. things that I wanted to point here. For instance, in the, well, first you see the feature, the thing that you said, so we have to define that there if you want to use API. And we use the present to say that, okay, this device implements the API functionality. But the thing that we use, and we decide that for implementation purposes, is that for instance, for the list of local IDs, instead of using the list directly, we put the list within a container. So for instance, when we were doing the implementation for Lisp, we found that useful to keep the code simple, even though it's not mandatory to define the Lisp configuration. Those are the kinds of things that came from implementation or from the RFC. So then another thing is on the right, for instance, you see the same thing with proxy IPRs, and then within the proxy IPR. And there on the bottom right, this is the thing that we are not sure yet how to do. But for instance, in the map cache, we will have mappings that will be static, and others that will be dynamically learned from map replies. So either we put two different containers, one being map cache, another map cache static, and then use the config flag on Yang to define, okay, these are mappings that have been configured, and these other are mappings that have been learned. Or either we put the flag within the mapping, as we have done with static. But okay, this is something to discussion. We'll stick with that. So next slide. And finally, first of all, for those of you that are not aware, as of now we already implementing netconf support at Lisp. So if you want to try to configure via netconf a Lisp device, you can give it a try. On that implementation, we have used a simplified version of this model. Not all the parts, but basically what you can do now is use the ITR configuration that I've shown you before to configure the Lisp ITR features. The hard part was to provide netconf support to Lisp, not to support the Yang model. So now that the netconf support is already there, eventually the rest of the features, the rest of the Yang model will implement and support. So that's all.
Any more questions for Alberto?
I didn't see any DBT stuff or Lisp. Did you leave the mapping system stuff intentionally out?
You mean like DBT nodes? So
Yeah.
We have not covered yet DBT in that sense. For instance, within the map server and MapResolve, we are allowed to define which kind of mapping system are you using, either ALT or DT, but the configuration for DBT nodes is not yet there.
So
Go ahead.
how do you expect to define multiple mapping systems? Should it be done separately or all together, or what? Do you have any ideas?
You mean like the configuration for the internals of mapping systems?
Well, there's DDT, there's alt, there's nerd, and some of the things you don't want to care about maybe, but some you do. If you want to supply data models for those mapping database transport systems, should it be done in one document or separate ones, or don't know?
I believe that probably it will depend on the complexity of the internals. It's the same thing as with the LCAP document, where we should stop in things. So, for instance, from the point of view of the ITRs and the components that have been defined here as mapping from the server, as of now, we list the different possibilities for mapping systems. So we list, okay, you can choose to use DDT, you can choose to use SALT. If the list goes on, we don't know what we will do.
I mean, that part's fine, but when you do use DDT and you want to be able to manage the DDT nodes, you need a Yang model for that, right?
Yes, absolutely. So that will be covered in the future rental. Yeah.
Okay, that's the plan. That's how you do it.
Yeah.
So this is Vina Armagon. Just to give another comment on that, the model for the map server right now does have the option of configuring what type of mapping system we're using. And let's say if it's DDT, that we need to configure routes on it or so on. So those parameters are there, enabling different route addresses, DDT route addresses, and so on. Same for the map resolver. But modeling a DDT node is, on its own for configuration is not included yet. As you showed, there were only 6 features: the ITR, ETR, map server resolver, and the PITR, PTR. But that's like the first version of the model. So for sure, the modeling the DDT nodes should be included eventually. And as Joel suggested, we'll look into whether these features should be divided into different modules, in which case we will have a DDT module as well, or we will add a new feature to this for DDT nodes.
One other thing from the Java room, Florin pointed out that RFC 6095 has some hooks for recursion, but that's an experimental RFC. It's not clear it's widely implemented. You might go ask folks if it's widely implemented, because if it's implemented, it might be useful, but probably you can't count on it.
Okay, thank you very much, Abdul. So, which leads us to the last part of this session. All the presentation have been done, so we have kind of open mic for any discussion you people want to bring up.
There is one obvious topic for folks to consider. What would you like us to work on, to propose to Deborah and the ISG as, okay, we've cleared the hurdles, what should we put in the charter? I doubt we can put all of the ideas everybody has put on the table into the charter. We probably can't finish all of the ideas people would like to work on. So we need to start the conversation first here and then on the list about what are the most important pieces.
Daryl Lewis, Cisco. I think that that we should attempt to be practical and focus our work around the use cases that are seeing implementers work on and customers and networking people deploy. And I think that a guide for that will be some of the use case documents that were presented as individual submissions recently. And also a focus on the types of work that Lisp ties into elsewhere in the IETF, like, for instance, the work related to NBO3. So I think that's a good, from my perspective, a good basis, and we can go from there.
This is Dino. Yeah, I agree with what Daryl said. I think we should give a chance to look at each of those use case documents and go into detail and see what's required of the base Lisp protocol. I think we'll find that a lot of stuff is already there, and that a lot of these use cases just have to be documented and show what parts of Lisp it uses rather than introducing new machinery. There's some that require some new machinery, but it's waiting for like new uses of map notify for like VM mobility use cases, the case in point. And there's some other, NAT traversal is a very important use case, especially with a lot of people wanting to do IPv6 over IPv4, and there's IPv4 NATs in the way, right? So these are all really important things work that needs to get done. So I think, I agree 100% with Daryl said. I think we should look at those use cases and then back channel into seeing what the protocols, if the protocol currently can support it. And I think, based on the detail of these use cases, they're very detailed, and there's already, in people's minds, a lot of the machinery is already there and implemented. We just have to make sure that these use cases, what I was always worried about, is that the use cases don't introduce something into the protocol that was done in an implementation but couldn't have been brought into the IETF because it was out of charter. So we need to do a diff to find out if these use cases versus what's in 6830 in the companion documents are much different. And if they're different, we have to decide if they need to be added to the protocol in BIS documents or separate documents or whatever. Because a lot of things are scattered now, and it would be nice to bring it together. So yeah, I think use cases are critical.
Larry Krieger, Cisco. I see Lisp as a good solution for NVO3 control plane, and since things re-chartered in NVO3 and opened things up for Lisp and BGP to do work on solutions for control plane for NVO3, that would be something on my list.
Question for NVO3 people. If I make the statement...
Start that over at the microphone, please.
Oh, sorry? What did you say?
Said start over at the microphone.
Oh, okay. So I'd like to ask a question. This is Dino. I'd like to ask a question of the MVO3 people. If I made this statement, tell me if you think it was true or false. If Lisp solves the VM mobility problem as defined in the use case document that's in this working group, is that the same use case as that of MVO3?
Larry Krieger, it's definitely one of the use cases. I don't know, just VM mobility.
What are the other use
covers
cases in MVO3?
being an overlay, right?
That's the solution to what use cases?
Network scaling. I mean, things that Lisp does, right?
Oh, so is there any use case in MVO3 that's not
The mic, Dino.
This is Dino again. Is there any use case in NVO3 that's not in Lisp's charter? Oh, I shouldn't say that. That Lisp can't do. I made it first specifically.
One possible consideration is Lucy Young. It's the NVO3 interworking with the VPN. Please.
With traditional L3 VPNs?
Larry Krieger again. So I'm not clear on all whether what multicast is currently in Lisp charter and covered, and what is experimental or what just being talked about. It's not in the charter, but multicast is important in NVO3, I think.
There's one RC and all the others are individual submissions.
Yeah. So maybe some work on a simple multicast.
Thank you, folks. If there's any other topics people want to bring up, feel free. Otherwise, we're going to give people back a little time.
Do we have status on the intro document?
It's very simple. Albert will submit a new version of the document because we were discussing with the ISG. There were 3 discussed to solve, which basically boiled down to 2. But anyway, Albert was working on that, and I'm pretty positive that with the next iteration we will solve the discuss and then move forward. Don't forget there are other 2 important documents, threats and impact. It's not only introduction.
And is that why the rechartering wasn't on the agenda this time?
Right.
Yes? Okay.
But as you see, we opened the discussion. I mean, this has any way to go on the mailing list. So.
Okay. Thank you.
Blue sheets, please. Did everybody sign for the blue sheets?
If anybody would like a T-shirt, you can come up and visit me. I only have double XL and XL left, but T-shirts are available because I don't want to bring them home.
Like I have to summarize enough. That's almost making embarrassing. You may not have had a cell phone and then you can jump off the
Because you have a choice to use all the radios it's like a multi-home site. And you guys encapsulate that phone and somebody located. You don't need something in the middle of the network to switch paths on. Because the middle of the network is just going to make one or the other. Locators are fixed on the network.